Hey guys, in this quick video, I'm going to show you a really nifty tip that you can use when solving for similarity between two triangles. So this is a HSC 2016 question 15. And basically the diagram pretty much has all the information within the question. And it's basically also given, just keep in mind that ABCD is actually a square. Therefore, you know that all the angles are right angles. And all the sides are obviously equal. So the first part of the question, it says, show that triangle FCB, so let's write that down, FCB and triangle BAT are similar triangles. So we're going to break this down into two things, right? Because when you're proving for similarity, you need to look at two sort of properties of the triangle, and that's the sides and that's the angles. So we know in similar triangles, angles are equal, and we know in similar triangles, the sides are in the same ratio. So let's start with the angles. And this is the tip that I want to give you. When you look at the two triangles that you have to prove, so you have a look at the diagram. So FCB is this one over here, right? And BAT is this large one over here. So it's really hard for you to be able to see, you know, what angles are equal and what angles correspond to the other angles, and the same idea for the sides. So this is where the tip comes in handy. So the way in which the question is written actually sort of gives you the answer, or it gives you a hint to know what to work towards. So I'm going to label F as 1, as in the first letter, C is the second letter, and B is the third letter. And I'm going to do the same for the second triangle. So B is the first letter, A is a second letter, and T is a third letter. So the way in which it's written, like I said, can help you determine the corresponding angles. So in the first triangle, let's take one of the angles. So I'm going to read it as 1, 2, 3. So I'm going to take the first letter, followed by the second, followed by the third. So that leaves me with angle FCB, right? And I'm going to look at the same pattern in the second triangle. So the first followed by the second, followed by the third. So that's BAT, right? And I know that if I'm trying to solve for similarity, I need to look for these pairs of angles and see or prove that these are equal. So you go back to your diagram and you look for FCB, is this one over here in red, and BAT is also this one in red. And what you realize is they are in fact equal, and the reason is because they're both 90 degrees, they're both angles in the square. So these are in fact equal. So we've done the pattern, the 1, 2, 3 pattern. Let's take another pattern to find the next angle, because we know there are obviously 3 angles in the triangle. So let's take now the first, followed by the third, followed by the second. So F, B, C. And let's do the same for the second. So the first, followed by the third, followed by the second. So it's angle B, TA. So, and we do the same thing with this one. We look at the diagram and we see if we can prove that these are the same, they're equal. So FBC is this one marked in purple, and BTA is this one here also marked in purple. So we need to show that these are equal in some way. And if you remember, I said at the beginning that ABCD was a square, and we know that opposite sides in a square are parallel, right? As in they're parallel to each other. So if this side is parallel to this side, then we can conclude that angle FBC, this one over here, and this angle over here are equal because of alternate angles. So once again, we've proved that they're equal because of alternate angles. Now, obviously, this is not the correct way to write your proof. You need to obviously have your reasons. But I just wanted to show you how you can deduce the corresponding angles and then use that to help you show that those two are equal. Because once you know what two angles you need to show are equal, it's easier for you to find the answer, as opposed to looking at the triangles and trying to figure out which ones are equal, right? So after this step, you've obviously proved that they're similar now, because the third angle must be equal because of the angle sum of the triangle. So you can essentially move on to the next question. But for the sake of this video, I'm going to go on to show you how to find the third angle, and then as well as the sides. In case the angles didn't work, then you obviously need the sides. So the second pattern, so the first pattern was 1, 2, 3. The second pattern was 1, 3, 2. And the last pattern we missed out was, and the reason I know this is because the middle letter here is C, and the middle letter here is B. So I know I'm missing F as my middle letter. So for this one, I'm going to go 3, 1, 2. So B, F, C. And what that does is it gets F as my middle angle. And I'm going to do the same for the second. So this triangle over here. So we said 3, 1, 2. So angle T, B, A. And there you go. So those are the corresponding angles in this triangles. And like I said, once you know which angles you're looking for to prove equal, then it's easier for you to prove that they're equal because you know what to look for. Now let's look at the sides. So the sides follow pretty much the same concept. So if you take one of the sides in the first triangle, so let's look at 1, 2, so that's side FC, and you put that over the next side, or you put that over the corresponding side in the second triangle. So 1, 2 again is BA. So those two are the corresponding sides, and obviously in similar triangles, they need to be in the same ratio as the following sides. So the first ones were 1, 2. So FC was 1, 2, BA was 1, 2. So next let's do 1, 3, right? So 1, 3 would be FB over 1, 3 in the second would be BT. And finally 2, 3. So CB over AT. And there you go. So just by the way the question is written, you can actually use it to your advantage. Once you know, I guess, the corresponding sides and the corresponding angles, then it's much easier for you to prove. It's much easier for you to prove for similarity, but also to find for unknown variables. Like in part 3, it says, find H in terms of X and Y. And I can almost guarantee you that you will need to use these corresponding sides in order for you to find H in terms of X and Y. I really hope that helped.